Back to our YouTube channel Incredible Max. In this video we will see the definition of linearly independent set and its properties. So before seeing the definition of linearly independent set, so we will see what is my linear combination. So for that, so we will take a vector space. Let V be a vector space over a field F, and S equal to some V1, V2, Vn be a subset of V. A vector V in the V is said to be a linear combination of S if V is equal to alpha 1 V1 plus alpha 2 V2 plus etc plus alpha n Vn, where this alpha 1, alpha 2, alpha n are scalars and they will be in F. So if V can be small v in capital V can be written as a linear combination of this S. So that is how the form V is equal to alpha 1 V1 plus alpha 2 V2 plus etc plus alpha n Vn. Then we call this as a linear combination. So here V is written as a linear combination of the elements of S. So this we call it as linear combination. So based on this we will see the linearly independent set. So linearly independent set, so we will know as Li definition. A subset S of V, that is S is a subset of V, is said to be linearly independent if alpha 1 V1 plus alpha 2 V2 plus etc plus alpha n Va equal to 0 implies alpha 1 equal to alpha 2 equal to alpha n equal to 0. That is the only solution of this equation alpha 1 V1 plus alpha 2 V2 plus etc alpha n Vn equal to 0 is alpha 1 equal to 0, alpha 2 equal to 0 and so on, alpha n equal to 0. That is, we say only solution of, so let us call this equation as 1, only solution of this one is the trivial solution or zero solution. There is no other solution other than the trivial solution. So a set satisfying this condition is called linearly independent set. So where this S is same as this one, so S will consist of elements V1, V2, Vn. Now a set which is not linearly independent is linearly dependent. So linearly dependent we denote as LD. So now we will see some properties or properties of linearly independent set. So basically linearly independent set is a subset of V. Properties 1. Any set containing 0 is always linearly dependent. Suppose if we take V is equal to R and F is equal to R, or V equal to R square. So let us take the S as some elements, so containing 0. So 0 means 0 comma 0. So 0 element in R2 is 0 comma 0, and let us take another element 1 comma 0. So here this set is linearly dependent because it contains 0 comma 0. So now we see why this set is linearly dependent. So for this we will frame the equation. So with these two vectors in S, so that is alpha 1 into 0 comma 0 plus alpha 2 into 1 comma 0 equal to 0. So the condition for linearly independent. Now we will solve this equation. So alpha 1, so collecting the components, alpha 1, so this is 0 plus alpha 2 to 1 comma 0 equal to 0. So here we have alpha 2 equal to 0, alpha 2 equal to 0, and alpha 1 can be any scalar. Suppose if we take alpha 1 to be any scalar, so let alpha 1 equal to some 2, then see, and alpha 2 equal to 0. So see what happens here. So alpha 2 equal to alpha 1 equal to 2. So 2 times 0 comma 0 plus alpha 1 is 0. So 0 times 1 comma 0. So we will check here. It is 0 comma 0 plus 0 comma 0 equal to 0. Here, so alpha 1 equal to 2 and alpha 2 equal to 0 satisfies this equation. So that is this solution is a non-trivial solution because alpha 1 is non-zero. So therefore this set is not linearly independent. So alpha 1 equal to 2 and alpha 2 equal to 0 satisfies equation 1. So this implies, so here the solution is non-trivial solution. So therefore non-trivial solution. So this implies set S equal to 0 comma 0 1 comma 0 is linearly dependent. It's not linearly independent, so it is linearly dependent. Suppose if we take the other set, okay, so S1 to be some 1 comma 0 and 0 comma 1, so we will check whether this is linearly independent or not, whether it's set. So using the definition of linear independent condition, so alpha 1 into V1, so V1 is 1 comma 0 plus alpha 2 into V2, so V2 is 0 comma 1 equal to 0. Let us solve this equation and check whether we get the trivial solution or not. So multiplying here, you will get alpha 1 comma 0 plus 0 comma alpha 2 equal to 0. So alpha plus 0, adding the first component and adding the second component, we get alpha 2. So the right hand side 0 means it's 0 comma 0. So equating, we will get alpha 1 equal to 0 and alpha 2 equal to 0. So this is the trivial solution. Therefore we get only the trivial solution. So this implies S1 is linearly independent. So this is the first property. So any set of properties, any set containing 0 is always linearly dependent. There is no need to check. Suppose if the set contains 0, then we can say that set is linearly dependent straight away. Second property, empty set is linearly independent. Empty set is linearly independent. And third property, a linearly independent set necessarily contain distinct vectors. So in a linearly independent set, the elements will not be repeated. Elements will not be repeated. So that is, the elements are not repeated. And fourth one, two vectors. Suppose if a set has only two vectors, so we will see what happens. Two vectors v1 and v2 are linearly independent if they are not scalar multiple of the other. Suppose if you take a set S, it can, suppose if S is 1, 1 and 2, 2. So here 2, 2 is 2 times the first element 1, 1. That is 2, 2 is 2 times the first element. So 2, 2 is a scalar multiple of 1, 1. So therefore this set does not have distinct vectors. So therefore S is linearly dependent. So the fifth property, every subset of a linearly independent set is linearly independent. Every subset of a linearly independent set is linearly independent. And sixth one, any superset of a linearly dependent set is linearly dependent. Seventh property, any two vectors in R2 is linearly independent if their determinant is non-zero. So third one is very important. The last one is very important property. So it's a shortcut trick, okay, to check the vectors are linearly independent or not. Suppose if you are given, so this can be replaced by Rn. Okay, so Rn. Suppose if we take V as R3, then suppose if we have vectors S equal to 1, 0, 0, 0, 1, 0, 0, 1, 1. So it is enough to, suppose we want to check this set S is linearly independent or not. So it is enough to find the determinant of this. Okay, so determinant will give you 1, 0, 0, 0, 1, 0, 0, 1, 1. So determinant of this will be equal to 1. So this is not equal to 0. So this implies S is linearly independent. Suppose the determinant is 0, then we say this set is linearly dependent. Okay. So these are some properties of linearly independent set. Okay. So if you like the content of this video, kindly like and subscribe. Also share with your friends. Thank you.